solving trigonometric equations. That's what we need to be able to do. It says solve each trigonometric equation in the specified domain and give a general solution. So we're going to solve it between 0 and 2 pi, and then we're going to do that general solution as well. This equation, when we go to solve it, we're only looking at this part of it, right? That other part is just the restriction on the domain. So this is what we need to solve. How are we going to do that? Combine like terms, right. So we'll move all the signs to one side and the numbers to the other. So if I subtract 3 sine from both sides, I have 5 sine over here. Subtract the 3 sine, I have 2 sine theta. And then I had 1 on the right, but I'm going to subtract 2. So I'll have -1. So combine like terms and then isolate the trig function. So I want to get the sine theta by itself. I need to divide both sides by 2, and I'll have sine theta, oops, try that again, sine theta equals -1/2. Now it's just like what we were looking at before. We need to go to the special triangle to figure out the reference angle for this one. The special triangle that we're going to use is the one that has a 1 and a 2 in it. So this one. And we just need to decide, is the reference angle pi over 3 or is it pi over 6? When we look at that special triangle, we're looking for which of those angles has a sine of 1 over 2. So sine is opposite over hypotenuse. If we choose pi over 3, the opposite is root 3 over the hypotenuse 2. Root 3 over 2 is not what we're looking for. So look at the pi over 6. Opposite is 1, hypotenuse is 2. So pi over 6 has a sine of 1 over 2, which means pi over 6 is the reference angle. And then we need to figure out which quadrants our actual answer is in. We're looking for a negative sign. So which quadrants have a negative sign value? So that's right, 3 and 4. And so then the angle that we're looking for in there these are sixths. I didn't draw them very accurately, but we know that all the way around to pi that would be 6 sixths. So this one must be 7 pi over 6. And what's the other one? 11 pi over 6. Those are the answers in the specified domain. So between 0 and 2 pi, we have 7 pi over 6 and 11 pi over 6. It says then give a general solution. So the general solution is just going to look like 7 pi over 6 and 11 pi over 6 plus 2 pi n, where n is an integer. Because we're going to get those two answers, but then if we go from either of those answers another full rotation, another 2 pi, we'll get another answer. And then if we go another 2 pi after that, we'll get another answer, and we can keep doing that. Or if we subtract 2 pi's. That's why it says n is an integer, because you can add or subtract 2 pi and you'll get another solution. So the same as the previous question, get the cosines together. So I'll subtract cosine from each side to leave me with 2 cosine theta on this side. And then add 1 to both sides. Oh. Did we do this question already? Basically, we had a 2 cosine theta equals 2. That's okay. Then divide by 2 and we get cos theta equals 1. Because you can't find a 1/1 on a special triangle, except for tangent, we need to look at the quadrantal angles for this. And we're right here. This is where cosine is equal to 1. Remember, the x coordinate is the cosine value. So 0 and 2 pi, but if you look at the domain it gives you, it's negative 2 pi to 2 pi. So your answers are actually going to be negative 2 pi, 0, and 2 pi. But if you wanted a general solution, it would just be 2 pi n.
Wait, so do you not have to write like something plus 2 pi n as like the starting point, or?
Well, not if the something is 0,
Oh, okay.
right? This one is asking you for what values of theta is cosecant theta undefined. Just have to think a little bit more about that one. Cosecant is the reciprocal of sine. So if cosecant is undefined, what's the reciprocal of undefined? Undefined is something over 0.
Also 0 over something.
0 over something is the reciprocal of that. So we're actually looking for where sine theta is equal to 0 over something, which is equal to 0. We're looking for where sine theta is equal to 0 because we're looking for where the cosecant is undefined. And the reciprocal of undefined is 0. So if we look at these quadrantal angles again, sine is the y value. Here's where sine is equal to 0. It's at 0 and pi and 2 pi, right? And 3 pi and 4 pi, every pi. So cosecant is going to be undefined. Zero, pi, and 2 pi. If we're working on that domain, it doesn't tell us here, but if we're working on that domain, oops. Between 0 and 2 pi, or let's do this. Between 0 and 2 pi like that, then it's just pi and 2 pi, if we don't include 0 in the domain, which often you'll see. Then the values are pi and 2 pi. The general solution would be what? Pi n. Every pi. Cosecant will be undefined. This is the last one that we're going to solve today, and we're just going to solve it on that domain from 0 to 2 pi. Let's start by figuring out what angle has a sine of 1 over root 2. And the answer is pi over 4. But instead of saying theta is equal to pi over 4, it's 3 theta that we're solving for. So we're going to say that 3 theta is equal to pi over 4. That's actually the reference angle, but because it's positive, it's one of the solutions. We want to be in the first and second quadrant for sine to be positive. So it's pi over 4, and what's the other one? Three pi over 4. But that's what 3 theta is equal to. How can we algebraically figure out what theta is equal to? Divide by 3, right. So we want to divide 3 theta by 3 to get theta. We'll divide pi over 4 by 3, and what do we get? pi over 12, and divide 3 pi over 4 by 3, and we get pi over 4. And that's good, except that it's not all of the answers. Because we found all of the angles for 3 theta that are between 0 and 2 pi, but not for theta. So if we were going to find another answer for 3 theta, we'd have pi over 4, 3 pi over 4. What would the next one be? So from pi over 4, if you go all the way around again, 9 pi over 4 would be another one. But what is 9 pi over 4 if we divide it by 3? Three pi over 4. That one's still good, 3 pi over 4, because it's still between 0 and 2 pi. What would be the next one after 9 pi over 4? 11 pi over 4? Because if we went all the way around and to there again, there's 8, 9, 10, 11. Oops, 11 pi over 4. I'm running out of space here, I'll just put it over here. 11 pi over 4. Divide that by 3 and you get 11 pi over 12. Is that still small enough? That's still just between 0 and pi, right? So keep going and finding more solutions until we get to a solution that's too big. If we kept going around again to this one, so we'll include 17 pi over 4 and 19 pi over 4, which for solutions here would be 17 pi over 12, 19 pi over 12. That's a lot of solutions. But those are all the solutions between 0 and 2 pi.